Good day, future engineers. We are already on the very last topic for the numerical methods or numerical analysis or numerical solutions to civil engineering problem. So previously we have already discussed numerical differentiation and as well numerical integration. And we have already know that differentiation describes the rate of change of whatever that the physical system is present there, or what it is, or what equations are being represented there. And we also know that to get the integral of a certain function, we can get those by getting the area beneath the curve. Now, we have already started the discussion on the differential equations. So in the differential equations, we have here the kuan nadre no masago lang both variables. There are several types of differential equations, and it is in differential equations that we try to see the relationship between two variables. When one changes, what will happen to the other one. So in this discussion, initially, this is divided into two major parts, and each major parts has also their subparts. For this specific discussion, for the first part, as a subpart of the major part, we are going to recall back, no, we're going to discuss ang ODE, and then what are the numerical methods atong i-apply or gamiton when we are trying to solve the ODE. And then discuss na to unsa ning IVP, the Euler's method, and then the Euler's modified Euler's method. So we already know that si calculus, differential equation, appears in all branches of science and engineering because they are very important. They give us detailed information regarding different physical systems. So there are variations of dependent variables as a function of the independent variables. So motong giingon sa inyo ha, that this is being applied in your especially sa itong mga major no nga kuan that involves calculations, na i-apply da na nga differential equations. So on the right side here we have a figure that shows a tank. So as you can see in the tank, na kuan na siya, there is a fluid being poured inside the tank, and then there's also a hole beneath. So not a pipe here where our inflow is, no, there is a where the fluid is coming from, and then at the bottom of the tank has also a hole where the fluid inside the tank is being discharged. So for example, in this specific case, let's say we are trying to find the height, and we know that the height is changing. No, it depends on the rate of the inflow and then the rate as well of the outflow. So in differential equation and this setting, we are trying to consider this system. We can formulate a mathematical model out of this physical system, and then from that mathematical model that will be solved, most generally it will be a form of a differential equation, and then we are going to solve that to get what we desired. For example, in this setting, let's say to get the depth of the fluid inside the tank at any time. So sa ato pa, differential equation is an equation that contains derivatives of an unknown function. The solution is the function that satisfies the differential equation. So just like the linear and the nonlinear equation, diba, the number that satisfies the equation, we call that the solution. In the differential equation, ang solution is dili lang yun siya murag kuno katong specific number. A function is also a solution of the differential equation if it satisfies the differential equation. So we have partial and or ordinary differential equations. We also call that ODE. So mo man itong focus no, the ODE. So unsay na sa ODE? An ordinary differential equation is any relation between a function of a single independent variable and its derivatives. So in the ODE, there is only one independent and one dependent variable. So generally, we have the x and the y. The x is the independent and the y as the dependent variable. So ODEs are classified in terms of order and degree. So natin ginatawag nga order and degree. When gani kag order, that is the highest derivative. Ang degree dayon is the exponent no or the power of the highest derivative. So for example, we have this differential equation. Unsa man ang highest derivative? The highest derivative is this one. This is the third derivative. That is the highest derivative. So ingon niya ang highest derivative is the order. Sa ato pa, the order for this ODE is 3. Karon ingon niya ang degree is the power of the highest derivative. Sa ato pa, the degree, ang exponent man ani di ba is naman mo siya exponent nga 1. Sa ato pa, the degree of this ODE is 1 degree. So generally, this type of ODE, we call this a third order ordinary differential equation. Same also with this one. This one, what is the highest derivative? The highest derivative is just 1. So it means this is of order 1. And then, ang degree din niya is the exponent no, of the highest derivative. So the exponent of the highest derivative is 2. So this is an order 1 ODE with a degree of 2. So ingana na siya pagkuhan. Ingana na siya determine sa order and degree of the ordinary differential equation. In the next discussion, we are going to lang to siya ng brief introduction on ODE, and in the next discussion, we are going to determine unsa tong major subdivision of ODE in terms of solving them using numerical analysis.